But hey everybody, how are we doing today? This is take 3 on our notes. I've recorded it twice with a black screen, so we're going to try the third time is the charm, they say. Again, we are getting ready to start our notes for the day. So just like when you open up worksheets, it is a PDF. And over here on the side, when you open it up, you may have to scroll down some more. You click on comments. The comments opens up a new toolbar across the top. And then you are able to come on over here and you can zoom that screen out. So again, all the little tools we need are right across the top of our screen. And we should be good to go to start. All right. So as we first start off, like always, we are in 7.1. This means Chapter 7 of our Pearson textbook, Section 1. Chapter 7, Section 1, Exponent Laws. You may be saying, Mr. C, hey, I thought we were just in Chapter 1. How are we now in Chapter 7? Well, you guys are in Algebra 1 Honors in middle school, which means you skipped 8th grade math. They learn all about exponents in pre-algebra. So we have to kind of like jump ahead to catch you up before we can start, because we need to know these rules and how they work when we deal with exponents and variables together. Okay? So now as we take a look at this here, you are going to see we have a base. The base is the big number, and the exponent is the little superscript at the top. We have to be very careful because we have to remember that our new vocabulary, a base, the base is the number that's being multiplied a set number of times. The exponent, the little superscript up here, that's the number that's telling us how many times do we multiply that base in a row. So, for example, if this was x squared, or x to the second power, you've done these before. But the nuts and bolts behind it is it's saying that we take the base 2 and we multiply it 2 times in a row, which then would give us 4. If we had a to the second power, it would be a times a. So that's how it's going to differ. We're going to start to see our bases being a variable of some sort. And so now all we're really doing is we're combining those exponents and applying them as needed according to our rules. There are several rules that can be applied to exponents. Each one of our sections in this particular chapter up to section 4 is all going to be about different rules. We're starting off with the first 2 today, and I am not going to be typing all these rules out, so we're going to be using a new feature, the text box. So we're going to grab this text box over here, and we can drag it out, and now you should be ready to type in it. So the first rule we're going to define is the 0 power rule. What do we do when something is raised to a power of 0? This example is 3x raised to the power of 0. Easiest rule we have. Anything raised to a power of 0 equals 1. Anything, doesn't matter what it is. You could take SpaghettiOs, raise it to the power of 0, and it's still going to end up being 1. That is just a rule that we have in math. You will notice in the last example that we do, they're going to try to trick us with that on our EOC test, so we have to be careful. But it looks daunting, not a big deal. Anytime you see anything raised to the power of 0, it ends up being 1. So I put that little smiley face up there because that's a happy rule. It makes things very easy for us. The next one we're going to deal with is this rule here where we have the negative power rule. So again, negative power rule, all we have to do is take the reciprocal of it. And then the power becomes positive. That's it. So if we're looking at this example, this is what? X to the negative 12th power. So the reciprocal, we remember in math, right? This is kind of sitting over that invisible 1 there. We take the reciprocal. So now that X has to go to the denominator, and the negative 12 becomes a positive 12. This one here, look, the x to the -1 power, it's in the denominator this time. So it has to go upstairs to the numerator. And it looks something like this. So x, but this would not be simplified. X to the first power divided by 1. We don't need to write all these ones. In fact, we wouldn't write a 1 there, and we don't write something is divided by 1. So we know anything divided by 1 is itself. So it would just be x. The other rules are not quite as complicated as that one. We look at it, and we have multiplication will be the one that we deal with in 7.2. These all have the very same thing to start with. The base stays the same, and we add the exponents. A to the third times a to the fourth. This equals a to the 3 plus 4 power. And then what? 3 plus 4 comes out to be 7. So pretty straightforward. Base stood the same. We add these two exponents. When we're dealing with power to power, that's our next chunk of little rules. And the base will stay the same for us. We multiply the exponents. If we want to write that so we can see what's actually happening. Okay, so this would then equal this. X to the 3 times 9 power. This is showing step by step, of course. Not so bad. Again, this is x to the third power, and then that whole thing is being raised to a power. So that is the power to power rule. And the last one. Again, base stays same. Only this time we are going to subtract the exponents. And this one here, I'm going to add a special note. Do the subtraction. Wherever the largest exponent is. So look at this. If we take a look, we have exponents in both with the same bases in both the numerator and the denominator. So we look at this real quick and we want to say, I can see that the bigger exponent is in the numerator. We have the bigger exponent here in the numerator. So all of our subtraction, we're going to do it all upstairs. And I'll explain to you in just a second what's really happening here. So we have n to the 9th power, and then we need to subtract. Base stays the same. Subtract those exponents. We end up with n to the 6th power. Now this is a shortcut rule here, guys. It's just a simple rule to do this. There's actually two different things going on here from our previous powers that we just talked about. A negative exponent power is happening and the multiplying powers. Look, we're taking, in essence, we just took this negative n to the 3rd power and we brought it upstairs. So if we want to follow our rules exactly to the letter so we know what's going on, we have n to the 9th power. We took this and we moved it upstairs. It becomes n to the -3 power. Then we applied another rule, this multiplication rule that said base stays the same, add the exponents. Okay, so base stays the same and we have 9 minus 3. And 9 minus 3 is 6. Rules, lots of rules. And not a difficult rule, but I just wanted you to know and see that this division rule really is a combination of two other rules. But by using these little asterisks here, it saves us a little bit of time, okay? Basically, base stays the same. We subtract those exponents and do the subtraction wherever the largest exponent is, whether that's the numerator or the denominator. Start to look at some of our examples. Our first two examples are pretty straightforward. Look, we're dealing with a negative exponent, and we're dealing with one variable. That's it. Again, in math, this is technically over 1. We have to take its reciprocal. So this, because it's negative exponent, has to come downstairs to your denominator. And the exponent will become positive. You are finished. This one again, because it's negative, well, it has to leave and go upstairs. All right, so it becomes x to the third power over 1. We should notice and say, hey, you know, Mr. C, we don't leave it like this. We know anything divided by 1 is itself. So that would be your final answer there. Our next example is kind of like a two-parter, and it's asking us, are these the same? We have to think. Remember, order of operations, these parentheses here on this side doesn't have it. So we have negative t raised to the power of 2. And on this side, we have negative t squared. There is clearly a difference. And it isn't just because, oh, there's a parenthesis. There's something different happening. And when you actually write this out, you can see. Okay? I'm going to say, just for fun, we'll say that t, because we'll evaluate these two as well. T equals 2 as we think about it. Okay, so this is, we have a negative t times a negative t, because it's saying this is everything in here is squared. So this whole thing is the base. Multiply it 2 times in a row. Let's look at this one. This time it's saying we have a negative and t is the base. Remember, there is an invisible 1 here. So this is negative 1 times t, and t is what's being raised to the power of 1. Not all of it. Notice, remember, see how this one here? Negative 1 was multiplied twice because we squared negative 1. Negative 1 times negative 1. And we squared t. T times t. So this would be negative 1 times t times t. Because this is like locked. It's handcuffed right to the thing that it touches. When it touches the parentheses, it's talking about everything inside. When it's not, it's only dealing with the variable, not the coefficient of the variable. So if t is actually 2, we would have negative 2 times negative 2, which equals 4. Here, we would have what? Negative 1 times 2 times 2. So this becomes negative 2 times 2, which gives us what? Negative 4. Notice how the answers are different. It's all because that parentheses did not include the coefficient of t. I'm going to give you a star here. Another example. What if they give us this? This time you can clearly, like, this is hidden math. Again, we don't always see that. This you can clearly see there is a coefficient on this t, or on the, I'm sorry, I drew an X this time. So there is a coefficient. Notice I have this starred, underlined, box it, highlight it. You may see this on homework or an EOC test. Right, we have to make sure as we're evaluating this or simplifying it, that square is definitely going to both. Well, 2 squared is 4, and then this just comes straight down. And you can see right there, there is your answer for this particular one. So maybe do this as like example 3.1. Right, good to know. We're going to need this. You're going to see it in your homework, I promise. Example 4. Well, now we're talking, look, we got a fraction. We have 3 different variables, and we have negatives in both the numerator and the denominator and a positive power. First thing we have to do is the negative power rule states take the reciprocal and then that power becomes positive. Well, what do we do with one that already has a positive power? Easy. Leave it alone. Do not mess with it. It is positive. It is happy right where it's at. It doesn't have to do anything. But this one is negative, so it has to go downstairs to that denominator. This one is negative, so it has to go upstairs to the numerator. So we're going to bring the z downstairs, and its exponent stays the same, becomes positive. That y is going to go upstairs. Do we write that 1? No, that is bad form in math. We don't have to write that. It's invisible math. So when it comes upstairs, the -1 becomes positive. Because it's a positive one, we don't have to represent that. So it's y times x to the third. Z to the second power, or z squared, is in the denominator, and you are finished. That right here would be the final answer. So when you're looking at these, all you have to look at is, okay, y is negative, y is going to be at the top, z is going to be at the bottom. So you should have an x and a y up top and a z in the bottom. And if we start doing that with speed, you can really start to improve this particular function. I guarantee that's going to be in the homework. Here comes one, and we have, again, 3 variables. We're including the 0 power rule, the negative power rule, and it says simplify and evaluate. And it gives us values for each of our things. When v is 2, when p is 4, when h is 2,671. That's a huge number. Whew. I hope we can do that. Let's slowly break this apart. So right now I can see, look, we have both positive and negatives. Everything is in a numerator. That means this whole thing is technically sitting over 1. We're going to have things moving on us. V to the third power, it's positive, so it stays up top. This one here is then one with the negative exponent. It has to go downstairs into the numerator. What was that 0 power rule? Remember, that was the easy one. We said anything to the power of 0, anything at all to the power of 0 equals 1. So if you have 2,671 all raised to the power of 0, it all equals 1. Anything times 1 is itself. So do we need to write a 1 in here? No. We've finished this. We just have to evaluate. This power of 0, man, guys, this is so easy. It helps us so much. They put it in there just to trick us. You get to pretty much just ignore them when we see them. Now, we want to look at this. So we said v equals 2. So we can use the law of substitution, plug that in. P equals 4. Law of substitution, let's plug that in. Make a little room here for us. You should know this law. All right. Now, we have to evaluate. Well, 2 times 2 times 2. That's 2 to the third power. So 2 times 2 is 4. 4 times 2 equals 8. So we're looking at 8 for our numerator. 4 squared is the same as 4 times 4. So 4 times 4 is 16. Please, guys, make sure that you reduce this. This reduces one more time. 8 goes into 8 one time. 8 goes into 16 2 times. 1/2. Maybe one of you looked at this, because I know this is something we have to practice. You say, oh, they're both even, so they're divisible by 2. Okay, so 2 goes into 8 4 times. And 2 goes into 16 8 times. Notice, oh, look at that. They're still even, so 2 goes into 4 2 times. 2 goes into 8 4 times. They're still even. 2 goes into 2 once. 2 goes into 4 2 times. Now, that was bad. clean that up. I got to get better writing with a mouse. They both reduce. So be careful, guys, on reducing fractions. Sometimes we don't see it at first, the first thing, but if you look, like if you didn't catch the 8 first time, you reduced it in half, you reduce it in half again, and then you keep going down and you end up getting it. 1/2 would then be the final answer there. Here is our last one. And I told you it was going to be a doozy. It says evaluate. Oh, we have like 10q to the 14th. Here's a, I don't even want to look at this one. It's so bad. Look, there's a negative power here. And then we got a negative power here. There's huge coefficients. I don't even know what this one is. The Greek letter lambda, by the way. And they want us to evaluate. It's our happy zero property, guys. We should be good at this by now. Anything. Look, it's all in parentheses. Anything raised to the power of 0 is just 1. So this entire thing, see the happy face and the 0, this entire thing is only 1. And that's it. Go ahead, guys, please make sure you're doing your homework. deltamath.com is where you need to do it at. And we have some very, very easy homework you should see. But what's going to happen is that this is going to actually start to build. When we learn the next power rule, they're going to use the 0 power rule with it. They're going to use this negative power rule. So we have to make sure we're learning thoroughly these rules as we go along. All right? Get out there, do your homework, finish it up.